All right. It's going to be a very short lesson. Well, today's lesson may not be so short, but the next two lessons, and then we're done. Okay, we're done for the year. Today and tomorrow. So hopefully we'll do 12-1. We'll finish 12-1 today. We'll do 12-2 tomorrow. Give you homework for both of those. We'll take a quiz on it, probably, I don't know, probably Tuesday. We'll use Monday to maybe go over these homeworks with you, and then that'll be kind of your review for your quiz. So we'll take the quiz probably Tuesday of next week. All right, so we'll review on Monday. We'll go over the homeworks on Monday, and then we will take the quiz on Tuesday. And then Wednesday, Thursday, Friday of next week, we'll review for the finals. That should be good. 3 days is plenty to review for the finals. Don't you think? Yes. All right, here we go. So let's talk about the word. Well, this says trigonometric ratios. All right, it's a big fancy word. It's taken from the word trigonometry. Let's write that down. Trigonometry. Basically, this is the study of angles. Okay, some people say study of triangles, but it's the study of angles. And we've studied angles before, but we haven't really done trigonometry. So trigonometry is the study of angles. A lot of times we just shorten it, so saying trigonometry all the time takes a little bit long. So what do you think we shorten it to? Just trig, all right? So when we say, we're studying trig, that's just short for trigonometry, all right? And the word sounds scary, especially this word trigonometric, all right? But it's really not that bad. I talked to so really in all my classes now, so now in my honors geometry, we've been doing trig, algebra 2, we've been doing trig, and in pre-calc, we've been doing trig. All right, now they've gone a lot further than what you guys are going to go. But in all my classes now, we are studying trigonometry. And I think if you ask them, they would say at first it might have seemed a little bit scary, but then when they started doing it, it really wasn't that bad. And some of them actually liked it. Can you believe that? All right. What we're going to do is we're going to just deal with the trig. Since we're only doing 2 lessons on this, we're only going to do trig with right triangles. All right, so we are only going to deal with right triangles. All right, so let's draw a right triangle and let's see what we're going to do with this. We're going to introduce some words that you've seen on your calculator, but you probably, my guess is, you probably have no clue what it means, how to use it, what it's there for, all that kind of stuff. And I don't blame you because you haven't been taught it yet, okay? There's no way you can learn it unless you've been taught it or unless you read about it yourself. So we got a right triangle right here. What we're going to do is, let's just call this ABC. Let's go ABC like this, all right? And if this is angle A right here, what side? We could call this BC or CB, but it's a lot easier if we just call it little a. Do you see that? I called it little a because it's opposite the capital A, angle A. So what do you think I'll call this side right here? Instead of calling it AC, call it little b, and this one right here, just little c. All right? That makes it easy, doesn't it? Okay. So what we're going to do, we're going to introduce 3 words to you. These 3 words are going to sound kind of weird. Actually, one of the words, not in your class, but in my honors class, we talked about it. But let's see, before I actually do that, what we're going to do is we're going to pick an angle. Not the right angle. We're going to pick one of these angles. These are called our acute angles. So I'm going to pick one of these angles. And what I'm going to do is I'm going to find a ratio. Remember that at the beginning of this lesson? It said trigonometric what? Ratios. What in the world is a ratio? Just real simple. What do you think a ratio is? Anybody? Like if I said like 2 to 3, 3 to 5, okay? I don't know, 7 to 10. You've seen that before, haven't you? Okay, that would be considered a ratio, but you could also write it, instead of 2:3, you could write it what? 2/3, or what? 3/5, or what? 7/10. Everybody got that? So these are ratios. So basically a ratio is just a what? The fractions, exactly right. Okay, it's a comparison. You're comparing one thing to another thing. All right, that's a fraction. That's what a fraction does. That's what a ratio is. That's what we're going to do in this triangle. So let's say I started, I'll tell you what, let's start with Let's get rid of this thing right here. Let's start with angle A since A goes first. Actually, before we do that, let's do something else. If I talk about angle A, what is side A in reference to angle A? Like if I compare them, like angle A is what? We've talked about this before. This is not new, right? Side A is what to angle A? It's not across from it. A lot of people say across. What word do we use? We don't say across from it. We say what? No. If it's across from something, it's opposite. We've done that, haven't we? We talked about the side opposite, the angle opposite. Yeah, we've talked about that a lot this year. Doesn't sound like it from your response, but we have. All right, so this side right here is opposite angle A. Everybody with me? I should have started with this one. What is side C in this right triangle? It's the hypotenuse. Very good. How do I know it's the hypotenuse? Because it's what? Because it's opposite the right angle. Okay, everybody with me on that? We've definitely done that before. So C is the hypotenuse. So I'm going to write that right there. I'm just going to shorthand it. Is that all right? Just put HYP for hypotenuse. So C is the hypotenuse. What is A? A would be what to this angle A? It would be opposite. I'll just shorten that as well. Just put OPP. All right? Now, somebody said this word, but it wasn't, but you said it for A, but it's actually B. This side right here is next to this angle. Do you see it? All right? The hypotenuse is also next to it as well, but it's the hypotenuse. So we always call this the hypotenuse. What do we call the side that's next to an angle? Somebody said it earlier, but you said it for this one, but it wasn't correct. Who said it? I forget who said it. Somebody said it. It's not parallel. Nothing's parallel here. What is it? It's adjacent. That's right. And I'm going to shorten adjacent just ADJ. All right? How do you spell adjacent, by the way? ACENT. Okay? But I'll just shorten it to ADJ. Is that all right? So this is very important. Okay, Benjamin? You need to pay attention. All right? You got nothing in front of you. That's the problem. Okay? You want to leave right now? Because it'll make it a lot easier for me instead of dealing with your nonsense. Because you're not paying attention anyway. You might as well just go. So I'll give you an option. You could leave, okay, or you could get a piece of paper out and take some notes on this. And that'll help you focus a little bit. So what's your choice? Tell me your choice. Because I'll give you I'll tell you what I want you to do unless you do your choice. Okay, we'll get it out and write some stuff down because other people are trying to learn and you're not allowing them to learn. Okay, so if I'm dealing with angle A, this is the opposite side, this is the adjacent side. Everybody see that? Okay, let's change colors a little bit. Let's go blue. What if I'm dealing with angle B? Is this side right here opposite angle B? No, which one's opposite angle B? Side B, little b, right. So I'll do this in blue. So what is this side right here to this angle B? This would be opposite, wouldn't it? You see that? So it depends what angle you're talking about, right? What is this side right here to angle B? It's adjacent, so I'll put it in blue. Now, what about C? It's still the hypotenuse, isn't it? So that really didn't change, did it? Okay? So it's really important which angle that you're talking about. If I'm talking about angle A, then this side is opposite, and this side is adjacent. If I'm talking about angle B, then this side B right here is opposite, and this side right here, A, is adjacent. This is still the hypotenuse no matter which angle you're talking about. That's really, really important for what we're going to do next. We okay with that part? All right. So now what we're going to do, I keep talking about these three words that we're going to talk about. So these three words deal with certain ratios. So I'm going to have a word that talks about a ratio, a comparison of one side to another, like the adjacent over the hypotenuse. I have a word that describes the adjacent side over the hypotenuse. I have a word that describes the opposite side, or sorry, what did I say adjacent? Yeah, I should have been using this angle right here. The adjacent over the hypotenuse. I got a word for that. And I got a word for the opposite over the hypotenuse. I got a word for the opposite over the adjacent. So I have words that describe a certain ratio, right? Why do we need to know these ratios? Because we're going to be able to solve for some missing parts of a right triangle that we couldn't solve for before. It used to be, if we had a right triangle and if I knew two sides of that right triangle, then I could find the third side. How did we do that? What if I knew two sides of a right triangle? Pythagorean theorem, very good. Okay, I could always find the third side. What if I knew two angles? Or what if I knew this was a right angle and I knew that angle right there? Let's say I knew that was 60 degrees. What would this be? How'd you do that? It's 30, 60, 90, correct? Or you go 180 minus 90 minus 60, right? So we do have ways to solve for missing sides and missing angles. But there are times when they just give you one side and they don't give you any angles, and you got to find that angle. I'm sorry, they give you two sides and you got to find the angle, all right? And we don't have any way to do that until we get to this stuff, okay? So the stuff that we're doing now, we're going to be able to find missing stuff, okay, missing things, and that we weren't able to do before. It would just be impossible to do it, all right? So that's what we're going to do. So I said we got three words. Let's do this in a different color. Here are the three words, and I'm just going to push this up just a little bit. Okay, you ready? Here we go. We have the word sign, S-I-N-E. It's not like a road sign, S-I-G-N. It's S-I-N-E. And we shorten it a little bit. We use the first three letters, so we just use S-I-N. Now, we don't say sin, all right? That's not what we say. And it's not because, like, sin's a bad thing and we don't want to sin, you know, it's against the Bible or something like that, okay? It has nothing to do with that, okay? But it's just a shortened way. But how do we say it? When you see that word S-I-N, what's the word? It's sign, okay? We don't say sin. We say what? Sign, all right? Now, let's do A, the sign of angle A. When I see that word sign, that automatically tells us that we take the ratio, we make a fraction out of the opposite side and the hypotenuse. That's what the word sign is telling us. It's like a code word. It's saying the sign of an angle. And you're thinking, okay, well, what does that mean? That means I take the opposite side and divide it by the hypotenuse. Everybody see that? That's what that word sign means. It's not a variable. I can't solve for sign. I don't get sign by itself. It's not a variable. It's just a word that describes you taking the opposite sign or side, the opposite side of angle A, and dividing it by the hypotenuse. That's what that means right there. Okay? You with me? All right, again, it's just a word that describes the opposite side divided by the hypotenuse. That's all that word means. All right? We got two other words. Now I'll try to squeeze it in here. We also have the cosine. And how do you think we shorten the cosine? C-O-S, right. But we say cosine. We don't say cos or anything like that, or cos. We say cosine. So again, if I wanted to take the cosine of a particular angle, what would I do? Well, you don't know because I haven't told you yet. This time you take the adjacent side and divide it by the hypotenuse. Okay, that's the cosine of the angle. Again, cosine's not a variable. You're not solving for cosine. It's just a word that describes taking the adjacent side and dividing it by the hypotenuse. You with me on that? Yeah. All right. We're going to put some numbers in here in a bit, all right, to make it a little bit more, to make a little more sense. We got a third word. Here's our third word, and it is tangent. All right. Again, how do you think we're going to shorthand that? T-A-N, right. So, again, we don't say tan. Every once in a while, you might be reading stuff really quick, and you might say tan of A or tan A. But for the most part, we say tangent, all right? All right, so tangent of A. Now here's what the tangent is. It again is just a word that describes a certain ratio between two sides of a right triangle. And what are those two sides? It's the opposite side divided by the adjacent side. All right? Let me, I'll show you in a sec. Well, I don't know if I'm going to show you today or not. Maybe tomorrow I'll show you how you use it on a calculator. Let me just make that a little smaller so I can put everything on the same page. All right, so here's what we're going to do. If I'm looking at angle A, and I want to find the sine of angle A, tell you what, let's put some numbers in here. All right, let's make this 3. Let's make this 4. So what's this going to be? 5. Good. All right, now watch. Everybody watching? Alani, get your head up, please. Come on, write this down. If you're writing it down, you're going to stay awake. Write it down and pay attention because you need to know what you're going to write down next. So if I take angle A and I want to do the opposite over the hypotenuse, which numbers am I going to use here? What is opposite angle A? It's 4, okay? So I write 4 over what? The hypotenuse. What's the hypotenuse? It's 5. And there you go. You set it up. Now, that's not all there is to it, okay? We're going to show you probably tomorrow how to actually solve for angle A with this. But it's very important right now to understand that the sine of the angle is the opposite over the hypotenuse. And I'm going to give you a quick, easy way to remember these instead of just sitting there memorizing. It's kind of a cool way to do that. All right? So let's do the other ones. Let's do the cosine of A. Let's put some numbers in. So what is the cosine of A? It's the what over the what? It's the adjacent over the hypotenuse. So up at angle A, which one's adjacent to angle A? 3. 3 is adjacent. Remember, 4 is opposite. 3 is adjacent to angle A. Which one's the hypotenuse? 5. So what's my fraction? 3 over 5. Or that's my ratio. Okay? These are trigonometric ratios. That's the name of this lesson. And that's what we're doing right here. Let's do the tangent. So I'm going to go, the tangent of A is equal to, again, we're looking at A, and I'm going to do the what? Opposite over the adjacent. Okay? So which one is opposite angle A? 4. Put that on top. Over the adjacent. What's adjacent to angle A? It's 3. Good. Everybody see that? So the stuff that we did right there is stuff that they're going to ask you to do on the homework. And it's stuff I'm going to ask you to do on a quiz. I'm going to give you a triangle. Okay? I'll give you, well, at least 2 sides. You could always find the third side, couldn't you? Right? By Pythagorean theorem. This was a Pythagorean triple, so I just made it super easy for you. But what I'm going to ask you to do is to write 3 trig ratios about this triangle. Okay? They word it differently. It says, state the 3 basic trig ratios of angle A. So this would be the answer. If I ask you to find the 3 trig ratios of angle A, that means I find the sine of the angle, the cosine of the angle, and the tangent of the angle. Now, how in the world am I going to remember that the sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent? Well, I got a way to do that. Keep that right there. Now watch, this is pretty cool. Every trig student knows this. All right, so now you're in on the loop, okay? You're in on the secret about how to learn these things right here. So the sine of A, so watch what I'm going to do. I'm going to write the S for sine is equal to what? Opposite over hypotenuse. Agreed? So I'm just going to put the first letters because I just want an easy way to remember this. And then what's the cosine? I'll put C equals. What's the cosine? Adjacent over hypotenuse. So I'll put adjacent over hypotenuse. And then what's the tangent? I'll put capital T. It's the opposite side over the adjacent side. Now what I'm going to do is I'm going to write this, and it's called a mnemonic device. You ever hear that? We've used like PEMDAS. What is PEMDAS? What does that mean to you? Please excuse my dear Aunt Sally, right? That's a mnemonic device. I'll spell the word for you. It's mnemonic, but it starts with an M. but then you got an N. The M is silent. I don't know why. It's weird, but mnemonic device. Whoops. You could probably think of other things that you learn, right? Like PEMDAS. That's not really a real word, is it? But it makes sense to you what it means, okay? PEMDAS means parentheses, exponents, multiplication, division, addition, subtraction. This is the same kind of thing. This is a mnemonic device. So what I'm going to do is I'm going to write it like this. SOH. This is just so I can remember it. And then CAH. And then TOA. So when you see this, you should understand what that means. It doesn't mean opposite times hypotenuse, does it? It just means there's the sine, there's the opposite, there's the hypotenuse. Okay? The C represents cosine, adjacent, hypotenuse. Tangent, opposite, and adjacent. Correct? All right? So this right here is my mnemonic device. Here's how most people say it. We say SOHCAHTOA. It's the first time you said it. It's not going to be the last time. SOHCAHTOA. We're going to say it on 3. Ready? 1, 2, 3. SOHCAHTOA. All right? Then you say it faster. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. All right? Sounds kind of cool. Almost sounds like, I don't know, some made-up language or something like that. But that's how you can remember your trig ratios. All right? SOHCAHTOA. Again, what does it mean? If I say so, you're thinking in your head, oh, so, that's S, that's sine, opposite over hypotenuse. You with me on that? So if it's the sine, you should remember, so, opposite over hypotenuse. The CAH, C-A-H, is what? Cosine is adjacent over hypotenuse. And then the TOA, what does the TOA represent? Tangent is opposite over adjacent. All right? So make sure you know this little device right there. Okay? It's super easy to remember. You just got to say it several times. SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. All right? If you say it over and over again, talk to an honors geometry kid, talk to a honors algebra 2 kid, a pre-calc kid, say SOHCAHTOA, they'll know exactly what you're talking about. Okay? They'll know that the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. Those are my 3 basic trig ratios. And that's the kind of stuff that they're going to ask you on a homework problem, and then obviously on a quiz. And we're not going to have a test on this. So there we go. All right. Let's do this. Let's do an example. This is right from the book. We'll call it example 1, since that's what they call it. All right. They give you a triangle again. Now this one, it's not going to be quite as easy as a 3, 4, 5, but it shouldn't be that difficult. All right. If you know Pythagorean theorem and you know your trig ratios, it should be good. Again, this only works when you have what kind of a triangle? A right triangle. It doesn't work with other ones. Only works with right triangles. Okay. So it's a little limited. But we use right triangles a lot. Okay, you look in this room. There's right triangles all over the place, or at least right angles, right? There's right angles all over the place. So we use them a lot. There we go. This is A. This is B. This is C. All right. So the question is, it says state the exact values, and they say decimal as well, so you could put it into a calculator, of the sine, cosine, and tangent. Now, sine, cosine, and tangent on your calculator is not going to help you do what we're doing right now. Okay, we are going to use that probably tomorrow. All right, sine, cosine, and tangent on your calculator. But right now, we're going to do exactly what we just did on the other one. So I want to find the exact values of sine, cosine, and tangent just of angle A. Now, I could have gone over here. Let's just do this in our head. I'm not going to write it down. I should have done this. What if I deal with angle B? What is the sine of angle B? I will write it down, okay? We wrote it in blue, so let's write it in blue. Yeah, I should have done both of these. So what's the ratio for the sine of angle B? Now, without looking, I'll scooch that down a little bit. Without looking, what is the sine? What over what is the sine? Opposite over hypotenuse, right? It's the SO, S-O-H, right? That's how you remember it, opposite over hypotenuse. So if I'm dealing with angle B, Which one is opposite, which number is opposite angle B? 3 over the hypotenuse, which is 5. Good. It's not too hard, is it? What's the cosine of angle B? Its cosine is CAH, C-A-H. So it's what over what first, for the numbers? Adjacent over hypotenuse. Which one's adjacent? Now you can say it. 4 over 5. You with me? And what is the tangent of angle B? Opposite over adjacent, because that's the TOA. Right? Which one is opposite angle B? 3. Which one's adjacent? 4. So it would be what? 3, if I could write, 3 over 4. Okay? It depends what angle you're using. Okay? Absolutely. Is that what you said? Yep. It all depends what angle you're using. Okay? Because look at the sine of angle A is 4 over 5. The sine of angle B is what? 3 over 5. The cosine of A was 3 over 5. The cosine of B is 4 over 5. Do you see any kind of relationship between that? Look, the sine of A and the cosine of B are the same numbers, aren't they? All right? And the cosine of A and the sine of B are the same numbers. Look at the tangent, though. What do we do with the tangent? The tangent of B was 3 over 4. The tangent of A is what? 4 over 3. They're just inverses of each other. Do you see that? So that's good to see. Let's keep going because we're running out of time the more I talk. So what do we want to do here? We want to find the sine, cosine, and tangent of angle A. So let's write that down. So the sine of angle A, cosine of angle A, and the tangent of angle A. There's a little problem. I know the opposite. What's the opposite of angle A? 5. What's the hypotenuse? What's the one that we don't know? We know this little b, or this adjacent side right here. Don't know this, do I? So I can find it, though. How do I find it? Pythagorean theorem. That's exactly right. So let's do a little work. So we don't know this. We'll call it little b since it's opposite angle B. All right, so how do we do this? B squared plus what? 5 squared equals 9 squared. So let's do the math. This one's not going to come out as pretty as a 3, 4, 5 triangle. This is not a Pythagorean triple. All right, but we can still figure it out. What's 5 squared? 25. And what's 9 squared? 81. What do we do with that 25? Subtract it. Minus 25. Okay, so b squared equals, I don't know, what's that? That's 11, or we'll make that a 7. That's a 6, and that's a what? 56? Is that right? Yep, just making sure. All right, so what's b equal to? Square root of 56. Now, for you guys, I'm going to allow you to keep it the square root of 56. Okay? We've talked very, very briefly about how to simplify that. I'm not going to worry about that right now. Let's just keep it square root of 56. I'm good with you guys just keeping it like that. So now, let's go back and find the sine, cosine, and tangent of angle A. So I'm dealing with angle A. What's the sine? What over what is the sine? Sine, S-O-H. What is it? Opposite over hypotenuse. Good. All right. So which one's opposite angle A? 5. Which one's the hypotenuse? 9. So that was easy, right? What about the cosine? Cosine is what over what? Adjacent over hypotenuse. CAH, C-A-H. Remember that one? That's how you remember it. Isn't that a good way to remember it? SOHCAHTOA? Yeah. So it's adjacent over hypotenuse. Which one's adjacent? Adjacent. It's not 9. I mean, 9 technically is adjacent to that angle, but 9 is always the hypotenuse. The square root of 56 is adjacent. So I just write the square root of 56 over the hypotenuse, which is 9. Just keep it like that. It's fine. For right now. If I had you longer, I would simplify this, but we only got one more lesson after this, so I'm fine if you keep it like that. What's the tangent? What over what? Opposite over adjacent, okay? 5 over what? Now, we got a little problem here. Square root of 56 is where? It's at the bottom. We've done this, and I would expect you to be able to do this. How do I get rid of that? Multiply the top and bottom by square root of 56. We've done that quite a bit, haven't we? So that shouldn't be too hard. So what's the top going to give us? 5 times the square root of 56 over just 56. And there you go. So those are my 3 trig ratios. And that's what they're asking right now. We're going to do a little bit more later, but right now, that's all they want you to be able to figure out, those trig ratios. So this would be an answer, this would be an answer, and this right there would be an answer. What do you think? Let's do another one. It's a little trickier. You know they always are, right? You know it's not always going to be as easy as the first example. But that's okay, right? We got that stuff. Look at that. If you just walked in the door and said you're going to learn this stuff, you're like, no way, okay? I don't know what any of that stuff means. But now you do, right? And now it's not that hard. Wouldn't you agree with that? Yeah. If you're paying attention. If you're paying attention, it shouldn't be that hard. But for those who have their heads down, not paying attention, you're going to have no clue how to do the quiz. All right. Example 2. They do this just a little different. They tell you what the cosine of this angle A is. They tell you it's 3 over 5. And what you want to do is you want to find the other 2. So if they tell you the cosine, what do they want you to find? The sine and the what? And the tangent, right? Okay? So they want you to find both of those. You're like, well, how am I going to do that? Well, a right triangle would help, wouldn't it? So let's draw a right triangle. It doesn't have to be to scale. All right, so there's a right triangle. And cosine of A. I could make this angle up here, A, or this one down the bottom. Let's just make this one down the bottom, A. Is that all right? Now, here's the key to this. Everybody watch. They didn't tell you any of the sides, did they? Nope. But they did tell you that the cosine was 3 over 5, which means what? The cosine of A. That means, what is the 3? That's the adjacent side. And what's the 5? That's the hypotenuse. So, guess what? We can put those 2 things on our right triangle now, can't we? Since I know the cosine is 3 over 5, that means the adjacent over the hypotenuse is 3 over 5. So which one's the adjacent one? This bottom one right here, right? So that's 3. And the hypotenuse is 5, and put a 5 right there. Does that make sense? So that was a little different, just a little bit, than what they did earlier. So you have to understand that the cosine is the adjacent over the hypotenuse. Since they gave it to you as a fraction, this side is the adjacent, that side's the hypotenuse. Again, it's a Pythagorean triple, isn't it? We did this earlier. So what's this side going to be without really doing any math at all? It's going to be 4. Okay? You could do Pythagorean theorem if you wanted to, but you're going to find out that it comes out to be 4 anyway. Now, it should be pretty easy now. So what do we have to find now? Sine of A. So let's do the sine of A. What's the sine? Opposite over hypotenuse. So what numbers? No, opposite. Opposite angle A is 4 over the hypotenuse, which is 5. So 4 over 5. So that's the answer for the sine of A. What about the tangent of A? Right, it's TOA, right? T-O-A, opposite over adjacent. So here's opposite, which is 4, and the adjacent is 3. You got it. You guys are catching on pretty quick. So that's what they're asking for right there. And you're probably wondering, why is this helpful? I mean, why do we need to know these ratios? Because of something. Let me see how far they go in this lesson. Let me see if I want to do this next part or not. Yeah, we can do this. We got 5 minutes? Yeah. Because eventually, next lesson, not this lesson, actually we're going to do a couple little things in this lesson that we can find. We're going to use this information, and we're going to use a calculator. We're going to use this information and a calculator to actually find the value of angle A. Okay, we're going to get angle A by itself. But we got to start somewhere, okay? We got to know our trig ratios, and then once we know that, we can use a calculator to solve for angle A. We'll do that tomorrow. I don't want to give it all away today, all right? But that's what we can do. If I find angle A, then I can find angle B, if that's angle B, very easily. So if I know angle A, how do I find angle B? Well, now I don't have to use a trig function. I can do something really basic. If I know what angle A is, let's say it's 50 degrees, how would I find this? You could go 180, but since it's a right triangle, you could go 90 minus this. So whatever this angle is, it doesn't matter. Okay, whatever that angle is, I could always find this one by just going 90 minus this. Okay? So the second angle should be pretty easy to find. It's the first angle that we have to do the trig with. All right? Does it make sense? Okay. Let's do something else. Let's do one of these triangles that we've talked about before. This is a this side and this side are equal to each other. So what are these two angles right here and here? 45. Very good. All right, so these two would be 45 degrees. And again, we'll call it ABC, like this. Let me see if I want to do this or not. Give me a sec. Yeah, let's do this. What if I called this AB, this hypotenuse, what if I just made it a 1? And there's a reason I'm going to make it a 1. You're really not going to know why, because that's later on. If we had time to do the whole entire chapter, you would see that. But let's just make that a 1. What's this side B going to be, and what's this side A going to be? Remember that? So we would divide it by the square root of 2, wouldn't we? Take the hypotenuse and divide it by the square root of 2. Let's simplify that. Can we do that in our head? Square root of 2 over square root of 2. You got it, okay? So A would be the square root of 2 over 2, and B would also be the square root of 2 over 2. Now, watch this. What I'm going to do is I'm going to find, this is the first time we're actually finding the sine, cosine, and tangent of an actual angle that we know, all right? So this is kind of interesting. Watch, you can do A or B, it doesn't matter. Let's do B. We've been doing A all day. Let's do sine of B. So what is the sine? What over what? Opposite. What's the sine? Opposite over hypotenuse, right? It's the SOH, S-O-H. So it's the opposite over hypotenuse. So let's deal with angle B, this B right here. What is the opposite side? Little b, which is what? Square root of 2 over 2, over the hypotenuse, which is over what? 1. Well, if I divide by 1, that doesn't really change it, does it? So that's just the square root of 2 over 2. Now, I shouldn't even put b. I know what b is. What's angle b? It's 45. So I could put 45 degrees right here, couldn't I? What I want you to do is watch this. We only got like a minute left, so we won't be able to get a whole lot of this done. I got to do something here. On your calculator, it's got to be in degrees. Right now, it's set at radians. Don't worry about what that is, but I got to make sure it's in degrees. All right, now watch this. If I hit the sine of 45 in my calculator, this is the first time we're using sine, cosine, and tangent in a calculator. So if I hit the sine of 45, on this calculator, I hit sine, then I hit 45, and then I hit enter, I get that number. You're like, well, that's not this. Well, hold on, just give me a second. It is this, because watch. This is the square root of 2 divided by 2. Let's see. Look, it's the same exact thing, isn't it? So I'm actually able to find the sine of 45 without using a calculator. I can use a right triangle, make the hypotenuse 1, and I can actually find out what the sine of 45 is. All right? The cosine of 45 is going to be the same exact thing, because the cosine is adjacent over hypotenuse. That's also going to be the square root of 2 over 2. All right? So let me, I gave you the assignment on Monday, but let me read it off to you. It's 1 through 16. So it's 12.1a, it's section 12.1a, and it's 1 through 16. So that's your homework. It's your next to last homework, okay? So make sure you do it. Make sure you do it.